Computing provides a vision for how the internet and how devices that are connected together can evolve. And in that vision, what happens is that the cloud becomes this ever more powerful aggregation of all of the powerful computing resources in the world. And the people, sort of at the edge of the cloud are using their end user devices like smartphones. And to some degree, as the cloud gets more powerful, these edge devices can become less powerful because they're relying more and more on the cloud to do things for them. So a lot of the apps that you use on your phone and even a lot of the web apps that you use in the browser are actually delegating a lot of their operations to the cloud. So when you do a search, for example, over your email, that search isn't happening locally. That search is being offloaded to the cloud if you're using web-based email, and the cloud is what's returning those answers. And so this sort of allows, again, the cloud gets more and more powerful, edge devices get simpler and less powerful, and to some degree, that evolution is kind of good. But there's some problems with this model. Some of the problems are technical. So one of the problems that has plagued cloud applications is the latency required to get data back and forth to the cloud. So imagine I have a dumb terminal type device where literally every keystroke has to send a packet of data to the cloud and then get a response. And that latency right now can cause unacceptable wait times, and it can make it difficult to interact with those devices. Now, that's a problem that we're going to solve. And one of the ways we're going to solve it is we're just going to start to distribute the cloud more. So rather than having these one big data centers, every cellular tower will have some computing co-located with it. We're already starting to see this happen where people are becoming more and more interested in putting powerful computing closer and closer to those edge devices. So again, right now you have maybe a couple of data centers in the country where all of this cloud computing is going on. In the future, you have thousands and tens of thousands and hundreds of thousands of small little data centers that are located much, much closer to the edge of the network, and that's going to tamp down the latency. Reliability, so problems here, right? And these are sort of the technical issues. Latency, reliability. So Leslie Lamport has a famous quote where he says, "A distributed system," and you can apply this to the cloud as well, "is a system on which I cannot do work because some machine that I have never heard of has failed." And you see this, from time to time. Certain types of cloud services go down. This happens less and less often. But when you rely on the cloud to do work, like if you've moved away from Microsoft or any sort of standalone Office product and you're using Google Docs or some sort of cloud-based document service, when that cloud goes down, suddenly you can't do any more work. And that can be pretty frustrating because your own computer's fine, right? There's just something broken in this cloud that you have no control over. And you're essentially just at the mercy of whoever's maintaining the system. But I think the deeper problems with the cloud model are sort of this issue of ownership and control. Because what happens when we start to move more and more data into the cloud is that this model requires that we trust a lot of infrastructure. We have to believe that if we upload sensitive information to the cloud, it's going to be protected, whether that's medical information or just the pictures that we took the other day that we want to share with some of our friends, but we don't want other people to see. So there's this issue of privacy, security, management, ownership in the cloud. And that's really because the cloud is sort of by design something that's going to be operated by a small number of entities. So a small number of entities are going to build this incredibly powerful sort of meta server that's going to serve all these different applications, and we're going to have personal control over less and less computing. And so this particular vision requires that we trust these entities. It requires that we provide them with lots of data about ourselves. As we start to upload more medical data to the cloud, so the heart rate information from my Fitbit is going into the cloud. Do I trust that the company that is using that data, receiving that data, isn't going to sell it to my insurance company that can then tell that I'm under a lot of stress and is going to charge me a higher rate? So there's all these sort of dark scenarios that essentially involve data sort of migrating around in the cloud, starting from some place where you might have thought it was innocuous and ending up somewhere else where it can be harmful. And so this is the kind of thing that we're going to all have to sort of get used to. The cloud also opens up lots of opportunities for surveillance. So whether that's from a government or some sort of corporation that wants to track us, better understand us, to sell us things, the cloud means that, again, we're aggregating all this data together. And so it creates much fewer points where some sort of entity can watch, can monitor, fewer companies that have to cooperate with the government in order to provide a lot of information about us. So on some level, this model is quite exciting because it means that the devices that we use can get simpler and simpler and simpler. They'll last longer. They'll be smaller. But on the other hand, it also means that we have to trust this cloud. And that's one of the reasons that has given birth to some of the efforts to actually create not this sort of extreme version of the client-server model, but a more decentralized internet where I don't have to trust the entities that provide all of this powerful computation.